Hi there and welcome to Math 7. This is still Unit 1, Lesson 9, looking at creating scale drawings here. So we're going to be making our own today. And so today in class, what you began to look at, first of all, was kind of doing some number talk, talking about what is great, or looking at what happens when we divide by a large number or a smaller number, what happens to those numbers within there, playing with some decimals and fractions. Then you moved into a section where you had a sketch of Noah's bedroom, which was not a scale drawing. And he wanted to create a floor plan that is a scale drawing. He said the actual length of the wall C was 4 meters. Let's just write this down real quick. 4 meters. And to represent wall C, added my C for the C. To represent wall C, he draws a segment 16 centimeters long. So let's say, for example, this here is 16 centimeters long there. So in reality, it's 4, but he draws a scale drawing and makes it 16. What is the scale he is using? Explain or show your reasoning. So what you talked about there was that for his scale, you kind of look at it this way. You take your scale, or your new one, and it becomes how it's related to the original. That's how I think about it, original. And so his scale, he happened to use 16 centimeters, and that was how it related to the original, which was 4 meters. It's one way of thinking about it, just in terms of the actual numbers being given there. But when you look at a scale, if you think back to our scale drawings, oftentimes you try to make these numbers equal to 1, or in particular try to get this number down to being 1, so that it's easier to draw as you make connections and to make that kind of that ratio thing. So number 2 says find another way to express that scale. So another way to express it could be to say something like, well, 16 and 4, or in this case here, 16 centimeters and 4 meters. I could think about reducing that down. 4 goes into here 4 times, so that really is 4 over 1. So I could say 4 centimeters to 1 meter. Another way of thinking about that. There are others, and that's just an example of how you might look at that. But that allows you to plug some numbers in and to make some measurements using some nice numbers as opposed to long, crazy numbers. 1 and 4 work a lot better than 4 and 16 when you're doing these kind of questions. So, and then it says, okay, the actual length of the wall, D, A and D, are 2.5 and 3.75 meters. Now we're saying our scale is 4 centimeters goes to 1 meter. Determine how long these walls will be on Noah's scale floor, and explain and show your reasoning. So if A was 2.5 meters, we're going to say to go from 1 meter to 4 centimeters is by a factor of multiplying by 4. So if I multiply this by 4, I end up with 8, 9, 10. I end up with 10 centimeters for A. For wall D is 3.75 meters. Again, I'm going to multiply it. I'm going from meters to centimeters. To get from here to here, I multiply by 4. So I multiply by 4. Sorry about my little mark there. Multiply by 4, and we end up with 20, 28, 29, 30, and we have 12, 13, 14, 15, 2 decimals, 1, 2, 1, 2. We have 15 centimeters there. All right, we do the same kind of thing for the Are You Ready for More, where they give you a different number and ask about whether that scale is going to work. Again, that's part of a class. Let's look at number 3 here, where it said to draw a sketch or a scale drawing of Utah. And it says Utah is about 270 miles wide and 350 miles tall. The upper right corner that's missing is about 110 miles wide and about 10 miles tall. So essentially Utah looks something like this. If you were to draw it out, it looks something like that. And so we're going to make a scale drawing of that using what they give us. For the first part, it says make a scale drawing of Utah where 1 centimeter represents 50 miles. So we're doing 1 centimeter to 50 miles. Or I could think of it like this, 1 to 50. 1 centimeter to 50 miles. Okay, so that's one way I can look at what that scale factor is going to be. Because they already gave me the actual measurements here, let's just do this as we go along. What that means is, like, if it's 270 miles wide, let's do the width. So the width part is, if my scale factor is 1 centimeter to 50 miles, and they're telling me that it's actually 270 miles long, I'm trying to find out how many centimeters long that's going to be. To do that, I could do some cross multiplying, and I end up with 270, and really I just want to slide that over there. I end up with 270 over 50 is going to be equal to x. That's what I'm looking for. So I don't really need to multiply that, because once I put it over there, I'm going to bring it back. It's a little bit of a shortcut there. And so 270 divided by 50 ends up being 5.4 centimeters. For the height, or how tall it is, whatever it might be, we take our 1 over 50, and we don't know how many centimeters that's going to be, but we know we're starting at 350. And so that becomes really 350 over 50, which is our x value, and that's going to equal, in this case here, 7 centimeters. So we know that if we're actually going to measure this out, we're going to have a shape that's going to be 7 centimeters tall. Let me draw it right over here. So I'm going to just try to get some room here. Don't have much. Let's see, so 7 centimeters tall. And then we're going to go 5.4 centimeters wide. So if I drop this here, 5.4, a little less than half. So we're going to go here and go 5.4. Something about there. We know it's not going to be a complete rectangle, so I have to find out that other part. We got that corner that's chopped out of there. So for the corner, we know that the corner is going to be 110 miles wide and 70 miles tall. So for the 110, let's do the wide part there. That's 150 equals x over 110, and that becomes 110, putting this over here, divided by 50, which ends up equaling 2.2 centimeters. Come back to that in a second. For the height, it's 150 is going to be equal to x over 70. Again, this moves over there, so we end up with 70 over 50, which ends up equaling 1.4 centimeters. Now I'm not done, because this is the part I'm going to chop out. So the best way to probably chop it out would be to continue the drawing real quick to make the whole rectangle. So I'm going to go ahead and go from 5.4 there and connect the dots over here. There's my 7 centimeters here, right? So I'm connecting everything together to make this, and then I need to chop out. This is what I'm going to take away. So I'm going to chop out from my width 2.2 centimeters, which is, there's 2 and 2.2 right about here. That's how much I'm going to chop off from the width side. And then for the length side, we're going to, or the tall side, we're going to chop off 1.4. So I'll go 1.4 about here. And so just as a little sketch, I can kind of draw a little line, draw a little line. And I know that I'm going to now eliminate this part right there, so that I have a shape that is going to be the right size for Utah. So that's what Utah should look like when it's all done. Something like that. That's my chunk that's out of it and all the way around. Again, this is what you did in your class today. And take your time. What I'm hearing a little bit from my teachers is that sometimes when you do your work, you're just a little quick and sloppy. Take your time, make it look good. There aren't a lot of questions here, so make it look as presentable as possible, that you actually did the work. Don't just go, oh, there, I'm done. That's not done. Actually measure it out. I'm going to skip this one for now, because again, you did this in class, but you'll use the same idea. Instead of 1 over 50, you do 1 over 75. And you plug that into all these initial values here and do the math work again. So the summary here is that you're creating a scale drawing of a floor plan, and you can do that by using the scale that they give you. Often that's down the bottom, and oftentimes you try to get one of these values equal to 1. In particular, whatever the scale is for the drawing you're making, try and get that down to 1 if possible. But it's up to you how you do that, because there are more than one way to express a scale. The different ways are going to be equivalent, and it's kind of a way of saying they're equal to each other. And so these are all different ways of saying the same thing. 1 inch to 4 feet is the same as half an inch to 2 feet, or a quarter inch to 1 foot. Lots of ways. And the scale you use is very much influenced by the choice of your scale, or the drawing I should say. The size you're drawing is influenced by the choice of the scale. You could say I want to use a 1 inch scale to 4 feet, or you could say I want 1 inch to 8 feet. And that's going to determine what kind of shape or picture you have in the end. Moving on to today's homework then, we had, first of all, a question that said you had a book And on the book on the website shows that it is 1.5 inches wide and 3 inches tall. Something like that for our book on a computer. The actual book is 9 inches wide, so in reality that whole bit's going to be 9 inches. The picture shows 1.5 and we have 9. What's the scale? Well, I could say that my scale is 1.5 inches compared to 9 inches, but as we said before, it's nice to get one of these numbers equal to 1. That's not that that's a wrong answer or anything, it's just not as easy to work with. So the way I could do that is I could think of it this way. I want to get the number, usually my new one, over to be 1, and in this case here I need to find out how many inches are going to equal 1 in this drawing. So if that's the case there, what happens is I cross multiply, and I have 1.5x equals 9. Okay, so the x goes to there, the 9 goes to there, 9 times 1 is 1. Now I want to get the x by itself, so I'll divide both sides by 1.5 to get that over there. And 9 divided by 1.5 tells me that x is going to equal 6. So our scale factor in this case really is going to be that 1 inch equals 6 inches. Seems funny to have inches to inches, but that's just the way that it is, and that's okay. So 1 inch to 6 inches is what we get for letter A, 1A. How tall is the actual book? Well, because of our scale, we're doing 1 and we're multiplying by 6 to get to the actual size. I started with 3, so 3 times 6 is going to be 18 inches. So I use my scale factor times 6 to multiply that actual height there. Number 2, we have the flag of Colombia. It's a rectangle that is 6 feet long with 3 horizontal stripes. The top stripe is 2 feet and the other ones are 1 and 1. So that's what that looks like there. It says to create a scale drawing of the Colombian flag with a scale of 1 centimeter to 2 feet. That's our first part there. So I know I can see B says make 2 centimeters 1 feet. So I'm going to break my paper part here just so I have some space to work with, okay? And this is going to be my A flag and my B flag, okay? So let's look at the A one. The A one, we want to make it 1 centimeter goes to 2 feet. That's what we're looking for. We already said that it was 6 feet across. So think of it this way. If I have 1 centimeter to 2 feet, I want to know how many centimeters it's going to take me to get to 6 feet. In this case, our scale factor, how do I get from 2 to 6, is a times 3. Alright, so in my case here, I want to multiply the top by 3, and I end up with 3 is going to be how long my flag is going to be. So we're doing centimeters, so we'll go 3 centimeters long for my length. 1, 2, 3 right there. Now for my width, I have a 2 for my initial little yellow stripe. So again, looking at our scale factor 1 to 2, we have 1 over 2, and we want to make our top part here 2. All right, so we're going to do 2. So if it's going to be 2, to go from 2 to 2 is times 1. So 1 times 1 is 1. So we'll go down 1 centimeter for our yellow stripe here. All right, that's going to be our first little bar. And again, if I draw that out, I have this and this. That's my first bit. These ones, though, I start off with 2. We can see what I'm doing is I'm essentially, what am I doing? This was 3, and this is 1. I'm dividing everything in half. So 6 times a half gives me 3. 2 times a half gives me 1. If this is 1, then my next bar won't be a whole one, will it? Right? It's going to be half of that, which is just half of a bar right there. And my other one will be another half right there. And I'll make my matching sides right here, just so we're nice and clean. I have 1 here and 1 here. So then I connect my dots on my flag, and we end up with a height right here of a half and another height of another half. So this is a 0.5 and a 0.5. So my overall length ends up being 3, and my overall height ends up being 1, 1.5, 2 centimeters long. That's the idea there. The same thing for B. We're going to use now a scale of 2 centimeters to 1 foot is the idea for the next one. Okay, so I started off with 6 feet. So to go to 6 feet, let's look at our scale here. 6 feet to go from 1 to 6. If this is a we're multiplying by 6, right? So we're multiplying by 6 to get there. So to go on the centimeter side, we're going to multiply by 6 times 6. So for my length, I'm first of all going to be 2 times 6, which is 12. All right? I'm out of space there, but let's just draw it right about there. I'll use a marker so we can see it maybe a little better. So we have 12 centimeters. Not a lot of space. There that is there. That's exciting. And then on how tall it's going to be, well, this was a total of 2, 3, 4. So we had 4 to start with. So let me erase that 4 there. To go from 1 to 4, it's times 4. So we're going to go and multiply this by 4. And 4 times 2 is 8. So we'd be somewhere right around here, coming down to 8. Is going to be the whole length of that flag. Right, so that makes a little bit of sense there, a little bit different. So we're looking at being 8 long and 12 wide for the entire length of the flag there. In terms of the actual stripes on it, right, the first one was 2 feet long, and so if we're going to go 2, we go 2 times top value 2 for 4, and we would say that our yellow stripe is at 4 centimeters, which is here and here. And draw that there, draw a line, connect the dots. Sorry, I need more space on my disk. And we connect our dots there for the 4s. So that would be our yellow space there, something like this. Alright, and then for the middle stripe, that's blue. If that was 4, because these are all half of that, we would say they're going to be at 2. And it said that this is going to be blue, so we go 2 for blue. And 2 over here for blue, and we connect our dots and we go here to here, and so that's the blue part, and then finally the last part is red, and that's down here. So it looks something along those lines for that flag there. So we made a smaller flag and then a larger flag, but they're all still a scale copy of the original flag, which was a 6x4. Alright, number 3, it says you have some scale copies of some triangles. For each pair of triangles listed, the area of the second triangle is how many times larger than the area of the first. So we're comparing the areas of these triangles. For me, the first thing I did was just find the area of each one. So to find the area of a triangle, you use the formula 1/2 of the base times the height. So in this case, half of 6 is 3, and 3 times 8 is 24. That's our area. Over here, half of the base, so 3/2 times 1/2 times 2. I looked at it this way. You can cut any number you want in half. The order doesn't matter. So half of 2 is 1, and 1 times 3/2 is 3/2 for B. Here I cut the 4 in half to get 2, and 2 times 3 is 6. And here I cut the 2 in half to get 1, so I end up with 8/3. So those are my areas for my shapes, right? 8/3, and then here we go. So to go from G to F, G is 6 and F is 24. So what they're asking is how many times larger. So what am I going to multiply 6 by to get to 24? Right? So it's like this. If I set it up, it's 6x equals 24. To solve that, I'll divide both sides by 6 to get the x by itself. That will go away. And then we have 24 divided by 6, which is 4. So it's 4 times larger for number A, or letter A. For B, it says G, which is 6, to B. And B is 3 over 2. So again, we're doing 6 times of number is going to equal 3 over 2. For this one, I'm going to divide both sides by 6, or if you want to think about it this way, I'm multiplying both sides by the reciprocal, right? 1 over 6. Now I have a nice fraction problem. 3 times 1 is 3, and 2 times 6 is 12. I'm not done yet. I want to reduce, because 3 goes into 12 4 times, so we end up with 1/4 times larger. So it's actually going to be a little smaller, isn't it now? For B to F, B is 3 over 2 and F is 24. So we have 3 over 2, x equals 24. I'm going to multiply by the reciprocal and the inverse there. 2 over 3 to get x by itself. I can reduce if I want to first and recognize that there are 8 3's inside of 24. And so now I'm left with 8 times 2, which equals 16. 8 times 2 is 16. For D, we have F is 24, and we're going 24 into H, which is 8 thirds. Again, 24x equals 8 over 3. I'm going to multiply by the reciprocal, 1 over 24, right? Divide 24. That same thing I did over here. 8 and 24, I have 1 8 there, which is 3 eighths there. 1 times 1 is 1, 3 times 3 is 9, and so I'm multiplying by a factor of, it's 1/9 the size. E, the same idea. G is 6, H is 8 thirds, so we have 6x equals 8 over 3, multiply by the reciprocal to get the x by itself. I could reduce right away if I chose to. I have 4 2's in there, and I have 3 2's in there. So I end up with 4 times 1 is 4, 3 times 3 is 9 for letter E. And letter F finally, H is 8 thirds. And we're going to go 8 thirds to 3 over 2. So 8 over 3, x equals 3 over 2. Multiply by the reciprocal, 3 over 8. And we end up with 3 times 3 is 9. And 8 times 2 is 16, and there's no reducing there, it just is what it is, and that's what we end up for that problem number there. Next one, we have some quadrilaterals right here, and it says to select all the quadrilaterals that are scaled copies of the unlabeled. So we're looking at this one to start with, and we're trying to determine if these other ones are scaled copies. This one begins with a unit length of a height of 2 and a width of 4. So what I'm going to look at first of all is, well, what are the ones I can automatically reject? I can automatically reject A because it's a parallelogram and it's just not quite going the right way, right? It's a rhombus, a little skewed there. I'm going to get rid of it. All gone. Same with F. Not going to work. So my next questions are going to be, do the other ones work? Well, let's see what's happening. B. B is increasing by 1. We go from 2 to 1. Got 1 there. And on the length, it's going 1, 2, 3, 4, 5, 6, 7, 8. We're adding 1 now. We're adding 4 more. I don't really see how that's going to work because here, this is like a times 2 on the top part, right? 4 times 2 is 8. But over here, 2 times 2 is not 3. So that's only going up 1. That's only going up like 1.5. So we would say, nope, not going to work for B. For C, we're going to go increase by 1, but we're also over here going to go increase by 2. So we have something happening that's a little different than before. We're going to be changing, okay? So how do I go from 2 to 3? Well, 2 to 3 means I'm adding a half of what I had before. I had 2, right? And I'm increasing by a scale factor of 1.5. Over here, think about what's half of 4. Half of 4 is 2, and that's what we're adding. So we would say yes for C, that's going to work just fine. E is the same one, so it has a scale factor of 1. For D, we're going from 4 to 2, and from 2 to 1. So we are basically cutting this in half, aren't we? So we're making a scale factor, and we're reducing down in size, so we'd say yes for D. G has 2 to start with, which is what we had before, and it gets to be 1 larger. Well, if you don't change this side, but you only do that one, it's not going to work. And for H, we see we're going up 2. We're doubling it. We're going from 2 to 4. So now we're 4, so that's a times 2 there. That looks good. Now, does the length go by times 2? Well, if it did, it'd be 4 times 2. It would be 8. 1, 2, 3, 4, 5, 6, 7, 8. It does, so we'd say yes to H. So for our answer choices, we would say C, D, E, and H. And you're looking at the scale factor there. So we have a scale factor times 2, we have a scale factor of times 1, we have a scale factor times a half, and a scale factor times 1.5. Alright, and that's what we're doing there for that one. On your own, you're going to, on a graph paper, draw a different scaled version of the original rectangle. So you're going to use this one and draw your own scaled version of it. So maybe instead of multiplying it by 2, you multiply maybe by 3. If you did that, you would take everything, instead of being 2 and 4, 2 times 3 is 6, 4 times 3 is 12, and you'd graph that out however you want to do that. Hope that helps in today's lesson. Good luck.